Welcome to the Maintainable Software Podcast, where we speak with seasoned practitioners who have helped organizations work past the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, we are joined by Jessica Kerr, who is a developer, writer, speaker, and Symmathecist, which we'll learn much more about in just a bit, who is joining us from St. Louis, Missouri. Jessica Kerr, we're so glad to have you on Maintainable.
Good morning. It's nice to be here, Robby.
So given your experience in the industry, what do you believe are a few common characteristics of maintainable software?
I think maintainable software is alive in the heads of the people who maintain it.
What do you mean by that?
I mean, the people who maintain it have like a mental model of the software system that is, it's not perfect, it's not complete, it never is, but it's reasonably accurate and it includes enough information that when the people need to modify a particular piece of the software, they know where to find out more.
Interesting. And are you the type of developer that enjoys building new applications versus, say, diving into an older existing application?
Oh, no way. Older applications are way more interesting. One, they're useful. Two, it's harder.
What do you mean by they're useful?
That application is there and it's being maintained because it's currently running in production and people are using it. Most greenfield projects never get anywhere. They never get into production, or if they do, people don't use them very much.
So out of curiosity, what is your current take on the metaphor that we use in our industry, technical debt? Do you use it at all?
Technical debt as a phrase has been useful and it's way surpassed and outlived its usefulness and is now often harmful. Technical debt was popular because it made sense to business people. It made sense to people who understood finance. But the problem is that metaphor goes way too far. And people who understand finance understand that debt is useful. But the debt that they're thinking of, financial debt, is fungible. You can pay off financial debt with any kind of money. You can swap it in and out for equity. You can sell it and buy it and chop it up into tranches and blah, blah, blah. You can't do that with technical debt. Every piece of technical debt, piece of code really, and properties of code and of architecture is unique. The only people who can fix it efficiently, if it needs fixed, are the people who understand that system. And it all has its unique costs and its unique trade-offs, and it is completely non-fungible.
So, you talked a little bit about how it's maybe outlived its usefulness. What are some ways that you would think about better phrasing that then as alternatives to that versus, say, I think there's sometimes a conversation about what's the difference between technical debt and, say, just bad code versus things that you would like to clean up at some point in the code base, or maybe annoyances or things that are impeding you as a software developer or as a team to keep up some, for lack of a better phrase, velocity, shipping on new features and stuff like that. But what alternatives have you kind of seen so far kind of pop up in ways of talking about something and knowing that we're kind of all on the same page about what that means?
My friend Artie Starr had a great answer for how to move on from the phrase technical debt. She says, how about we use escalating risk? Because it's not debt that we can sell. It's risk that we're accepting. And sometimes you accept risk. For instance, if you wind up never changing the software, if it's one of those greenfield projects that never gets off the ground and becomes useful, then that risk is not a problem. It's not triggered. We don't suffer from it. But if this is a legacy system, where by legacy I mean valuable, that's in production and people are using it all the time and counting on it, then it's real risk.
That's interesting. I think I saw that tweet the other day too, and I don't think I didn't go off and read or watch. Was it a video that she posted, like a conference video or something, or is it an article?
This tweet was from a couple years ago, and it was at a conference talk, but I just tweeted a picture with it. I'll send you a link.
All right. Yeah, that'd be great. I'll include that in the show notes for people. I think I'm trying to imagine a group of my developers talking about escalating a risk, and I don't think they use the word risk enough as it is to think about how like to kind of wrap their head around what escalating risk might mean. And how would you try to explain that to a group of software developers in terms of phrasing that in a way that's, if they're talking about, okay, we know that there's some things we need to take care of at some point, but or maybe a better question is, when you know that there's some technical debt or escalating risk, or there's these compounding problems within the code base, what effective ways have you seen teams organize that work and prioritize that?
Oh, I like to think of it as the way Google used to talk about having 20% time to work on whatever you found important. I think our developers need that. We should be spending a good chunk of our time, maybe it's 80%, whatever, it's reasonable ballpark, using the system we have in order to improve the software. And the other 20% improving the system we have, which sometimes that means improving the architecture of the software, the design of the code.
Earlier, you touched on a trait of maintainable software is that the developers can individually have a good mental model of this, the system. Do you think that's
not individually, collectively?
Just collectively? And so does that mean there's people that know certain areas more so than others, and that's okay versus everybody trying to have that?
Yes, as long as they're on the same team. I've just finished the book Team Topologies recently, and one of the crucial pieces of that is that a base assumption is the unit of delivery of software is a team. And now you could have a one-person team, but more likely you have more people on it than that. But everyone whose input is necessary, delivering the software is on one team, and that is where delivery happens, not in the individual.
Interesting.
Unless it's a very tiny team.
How do you find that teams are able to make sure that there's enough, say, cross-pollination of that mental model so that you don't have, say, a single point of failure with, say, someone leaves or a team or something, and they're like, oh, we don't know how that works at all?
The only way I've seen mental models transfer, really, we think that if we draw a diagram that it's communicative, but this is important. That diagram is highly communicative to everyone who was there and participated in drawing it. And to other people, it's rare. It rarely communicates half as much as you think it does. The way that I do see mental models transfer is pairing and mobbing. Mob programming especially, I especially like that one because one of the rules of mob programming is that the person typing doesn't make decisions. They only implement decisions that are voiced by others, which puts everything out into vocal space. And then people can ask questions, and that really brings a mental model to coalesce in a group.
You find that's useful when people are on a team working on making changes to something, or just reviewing something is a good effective way to do that as well?
I haven't seen mob programming for reviewing something. Often it's becoming familiar with something, so that would count.
It's a safe assumption that you're probably more often on team refactor than rewrite.
Yes. I mean, rewrite. Yeah. If I was going to do a rewrite, I would see it as a series of refactor into smaller bits, and then migrating from bit to bit, from like old bit to new bit. But one of the beauties of working with software that is currently in production is that our job isn't to write software. Let's face it, it isn't in greenfield either. We can just pretend it is for longer. Our job is to change software. Therefore, we don't design code. I mean, that's a part of our job, but the much bigger, more honest description of our job is designing change. And that includes way more than writing some new code or changing some existing code. It includes getting the production system from there to here safely.
That is like lighting a huge light bulb in my head right now. And so I was thinking about some changes that I was making to some code yesterday in a conversation recently with a developer that felt like they were struggling a little bit because they weren't getting to sit down and just write new code and new features enough. And were just feeling like they were just constantly being asked to work on making improvements or some smaller little changes here and there. And they weren't able to, say, get into a state of flow that they felt like they used to when they would work on newer applications. In one of your articles, I'm sure I know you've given a number of talks related to it as well. On the origins of opera and the future of programming, you conveyed that software is not a craft and also said that software is not an art. What do you mean by this?
Software is not a craft because we don't belong to a bunch of guilds who can define the best way to do something. There is no best way to write code. And what we call best practices are just like popular. Every piece of software is unique and different. Everyone is its own little piece of reality that we have crafted and that affects our world. There I used the word crafted, but we aren't craftsmen in this sense that back in the Middle Ages, they could have guilds because there were like well-defined, what does it mean for a cabinet to be good? And also, software is not an art because what we're building isn't just an expression of us. It's more physical. It's more fundamental to how the world works anymore because we change how the world works in software. Everything is new. And, when I pick up my phone, I like to think of my phone these days as a magic wand. And I download spells to it, which are the different apps, because we create magic in the sense of we change how the world reacts to humans, to what we do, and we can make things happen with a flick of our wand that used to be really hard or take a lot of work or not be accomplishable at all. Of course, it's not magic because it's technology, because we understand how it works. But to people who don't understand software, it might look like magic. Anyway, software is more physical than art. Art is much more expressive about our experiences. And it's too new. Every piece of software is always new for it to be a well-defined craft. And we as developers, we need to combine these things. I mean, do we care about how well crafted the cabinet is? In our case, the code and the architecture. Yes, but only insofar as how it affects the experience of the people using the software or the developers writing software to use our software in the case of services. So it combines those elements of craft and art into something new. That article, I describe developing software in a team as forming a Symmathecist. Symmathecist is a system that's based on mutual learning. We're always learning from the software, how it works, what it does, what errors it throws, what data it updates, whether people use it. And it's always learning from us because we change it. And together, the people on the team and the running software, and again, this is another reason to like working on existing software because it is running in production. It is teaching us. We have an active Symmathecist going on. And that's my favorite definition of what software is about. It's not a craft. It's not an art. It's the practice of Symmathecist.
Interesting. Prior to me becoming a software developer as a profession, I painted houses for 3 years after I dropped out of high school. And so that was a craft. There was a approach to that. I was an apprentice. I learned the value of prep work before you just don't immediately start painting, right? You go through, there's all these steps you have to go through. And if you want the painting to go well, you have to do all this prep work ahead of time and learn to really care about the quality of things. And I know that there's been a lot of conversations and there's a lot of literature and books in our industry talking about being a craftsman or craftsperson, or you make an interesting point about how that's best practices are often, say, just things that are popularized in our industry by people that have been around for a number of years. What advice can you give to people that are kind of coming into the industry and they're thinking, all right, so how do I hone in on my skills to be a good, say, software developer? Is it that I still need to learn some skills, and am I learning something different? And because I don't know that the education tracks necessarily produce people that are thinking of things in this kind of slightly more abstract way. I think maybe that you're kind of advocating and like speaking to just like what's actually happening? Because I know that people come out like, all right, I know how to do these 10 things with code, or and this is my track record. I built these 10, little small apps to show you my skill set. But how do you speak to, like, say, junior developers that are coming into the industry and to give them something tangible? Like, well, what should they be focusing on? How they think about what they should be investing their time on, improving their, for lack of a better term, craft.
Well, there's craft to it, right? That's a component. Like when you learned painting, you learned the best ways to paint, and you learned all the prep steps and necessary bits to applying paint in a professional manner, in a consistent way. And that's an important skill. You can't be a painter, like an artist kind of painter, if you don't know how to use paint, how to square off the canvas, and use a brush and mix the paint and clean the brushes and all that stuff. That is totally a necessary skill. But in house painting, once you learn how to paint a wall well, you can spend your entire life painting walls well in that way. And you'll get little bits of expertise. You'll learn how to deal with like the corner cases of weirdly shaped walls and coved ceilings and walls with lots of holes in them and stuff. But overall, you'll do the same thing. Software's never that. So yes, learn the skills. Never think you're done. In the beginning of your career, you're going to wind up writing the software that people tell you to write and doing what they think is a good idea. But as you advance, software developers moving from junior to senior to higher levels widen our view of the system. Okay, because our job isn't writing code. Our job isn't building and operating software either. I mean, at some point they pay us to do that. But as we move up, just like our job is to design change, we're designing change in a system that includes software. But it also includes the humans using the software, the other software systems that call into our software, and the things underneath it that we call into, and all the tools, of course. And when you think about it as designing a system, one, it's totally overwhelming. This is a reason that teams are larger than one person, because we can't have all this in our heads. The best we can do is collectively gather the details we need for a particular change at a particular time. We have more options. Maybe we don't need to add a button for this thing. Maybe we need to change what an existing button does, or more likely, maybe we need to change the way we communicate to people what they need to do. In a small enough company, the answer might be just going and talking to the people using the software, and the solution is actually completely different. Don't use our software for this at all. Maybe we don't need to add a blog to our website. Maybe we should use WordPress, kind of thing. When you look at your job as participating in a system that you're changing, you have a lot more options than just coding.
I think that's true. What's one of the best lessons you learned early on in your career?
One of the lessons I learned kind of early was that what people ask you to do isn't necessarily what they want you to do. One of my first jobs, my very first job, was in telecom. And one of our first customers, our job was to implement our software and then hand it off to them. And we did that. I'm actually really proud of how our team did that. We wrote the provisioning software and we implemented the new bits that our customer needed. And we worked with them, with the customer's team closely. And indeed, we handed it off to them. Now they did hire one of the people on our team, so they got that transfer of mental model onto their team, which was very helpful. But later I realized that that wasn't really my company's business model. I mean, as a vendor, they wanted to provide continuing services. And it made me kind of sad that with that particular business model, which fortunately I don't think is nearly as typical as software as a service now, which has a much healthier dynamic to it, it made me sad that making the software really good and easy to change was kind of a negative for that particular business model. But that was okay because our team really did that and I feel proud of it. Anyway, and in the end, someone told me as we were working on, this was possibly a different project, a really big project, and it was just impossible. There was no way it was going to get done. And there was a consultant who wisely told me, look, this project was about $1 billion and it's going to fail. And the person in charge of it is going to get his promotion. And that's all he cares about. And it did fail and he did get promoted. And it just, you know what? Sometimes it doesn't actually matter. Larry Weinberg says in Secrets of Consulting, he calls it the law of the twins. Most of the time, what we do has no effect on the world. But we can still be proud of the effect we have on the people on our team, the people who are our customers. And sometimes whether the software is beautiful makes no difference at all because it doesn't get anywhere. But whether we learned something, whether we formed good relationships, whether maybe the people that we met and the customers that we worked with and the people that we had a positive impact on, in a future job, we may form a team with them because we get most of our jobs through networking that does something amazing. So the effects we intend to have in the world often have nothing to do with the effects that we actually have. So, keep working, keep learning, and be really nice to each other.
I think that's a very important thing to convey. And I'm thinking about how there's been a number of projects where, there might have felt like they were doomed in some ways. Like, was this actually going to get used, or will the client be able to actually sell this as a service to people? Will people use this? And, I mentioned earlier that, my business has been focusing primarily on working with companies that have software that's been around for a while, mainly because they've already passed that early phase, because it was so difficult to look back on our portfolio of projects that we work on and know that it was kind of a graveyard. And it was disappointing. And I think our employee, we're a small software consultancy, but we had higher turnover back then. And I often wonder if some of that was related to the fact that there was that lack of long-term, like, look at what we did, and feeling pride in the work you did, and kind of just being like, well, we put a lot of energy into try to do as best of a job as we could to get them something that was what they needed to kind of go out to market, and they weren't able to do it. And sometimes it's hard not to feel like we're a failure for somehow being part of that process, but it's a collective process in that. And that can even happen with software projects that you're working on that have been around for a while. Like, sometimes the things you work on don't work out, or maybe things get scrapped halfway through it. And
sometimes the features they ask you to implement make the software worse.
There's a lot of things that go into that. And I think that's just like, we have to build up some thick skin of knowing that there's like, well, we're still getting to work as a team on these things. We're experimenting with things where not everybody that's making the decisions has all the answers. And that's part of the process. And it's like, they're learning through that process too. And it's not that they're making bad decisions. I think we want to all believe that our stakeholders are making good decisions
based on the information that they have, which is very different than the information we have.
It's true. And we often, as I think in our developers, it's easy for us to turn back and look at, get blame or something and be like, who wrote this code? Who made this decision 3 years ago? And that person, it may or may not be there, or it might be you. And then there's always someone else to blame. Well, the client asked me to do this, or the stakeholder made the decision and they were stupid.
Yeah, there's some context that person was in that is not our context now.
And I think we can all benefit from being a little bit more empathetic to previous developers and the stakeholders that have been around as well. And they're not, I don't think everybody out there, don't get me wrong, there's definitely people that are harmful in the world, but I don't believe that most of the time we're working with those people. We'll be back with our interview with Jessica in just a moment. Hi, it's me, Robby. I wanted to take a quick moment to thank you for making time to listen to Maintainable. I also really want to thank those who have spent some time writing reviews on Apple Podcasts and Stitcher. I really appreciate all the kind reviews. Those are really helping get the word out. If you haven't done that yet, feel free to write a review as well. Also, do you know someone in our industry that I should be speaking with on Maintainable? Shoot me an email to Robby with a Y at maintainable.fm. Or if you just want to say hello and ask me a question, you can reach me there as well. I'm curious to talk a little bit about, say, onboarding developers to a team, because you talked about mental models, earlier, and I want to maybe provide some advice. So let's say you've been on a software project for a number of years. Maybe you have the benefit of being there since day one. I don't think that's always often the case, but your team is going to be bringing in a few new developers soon. What advice can you offer them on how to prepare if they haven't really had any new people come into the project in quite some time?
When you have a new person and you haven't had a new person in a long time, prepare yourself to learn some stuff. Because you have this inside perspective. And having that inside perspective, it's impossible for you to see what the experience of this software system is from the outside. And you're about to get an opportunity for that. And it can be hard to appreciate that. And specifically, you'll only get that information if you make it clear. I don't even want to say make it clear. I want to say if the person coming on really feels like you want that information. So whenever the new person, you're trying to show them the ropes, show them how the system works, show them how the things fit together. Whenever they make a face, ask them, "Ooh, why does this surprise you?" Or tell me what just surprised you. And then whatever they reply, your first answer is thank you. Because if you appreciate that different perspective that they have, then they'll continue to provide it.
That is some really valuable advice there. Can you speak to those same developers that have been around for a while when they bring in new people? And let's say you've got some new people on your team and there's, and you've maybe in the first couple of weeks, you showed them the ropes and they asked a couple of questions. And then it's now been 3 or 6 months later and they're asking a question and you're like, I already answered this.
If you have to answer the same question over and over again, then ask, how could I change this system to make the answer to that question clear? Because another property of maintainable software is that it explains itself. My favorite legacy project I was ever on was some serious legacy. It was a big Java project with its own custom ORM. It was written around 2000, and 10 years later, it adhered very strictly to the exact same coding standards that were current in 2000. And the consistency was beautiful, but my favorite thing about it was it had these great admin screens that would show you what was in the cache of that custom ORM that didn't work. It had some serious design flaws, but it would show you what was going on. And when you have that kind of visibility to see what's happening, whatever it is, that important question that you need to ask about the software, can we change the software system so that it's obvious? Don't change the people so that they magically become smart. Oh, Aaron Blahoviak has a gorgeous post about the sufficiently smart engineer. And if you think that if that new engineer were just smarter, they wouldn't have to ask these questions over and over again. No, there is no sufficiently smart engineer to hold the system in their heads. That's not a thing, especially not to come into an existing system and load it into our heads. That is way, way harder than building it and living and breathing it and it being partly the output of what was already in your head. There's no sufficiently smart engineer. Make the system teach.
I think that's some wise advice there. I'm curious if there's, you were advising that they, ahead of those people joining their team, to prepare to learn. I think that's a good thing. Are there some tangible things that they could start doing to maybe think about how they would plan out a way to start having some of those conversations? like, is that something you think should just kind of happen ad hoc, or do you feel like there should be a benefit from like, okay, we're going to have a schedule, we're going to talk through different areas, or should you throw people into the deep end and like give them a task to start making some changes, or after they get the application running in their development mire, like?
Well, I would plan on pairing, or even better, mob programming. Oh, mob programming would be great, because a great first week would involve a lot of mob programming with the whole team, where not only is the new person encouraged to ask some questions, but the new person is going to see existing people asking questions and see that individuals on the team don't know the whole system, but collectively they do. So that really opens it up as, yes, you're not expected to know everything. You're never going to know everything. That's really encouraging. And then, I just want to pair most of the time for 6 months on a large legacy system. And give people a basic overview of the outline and then learn from their questions. But in general, besides like the high level framework, which everybody is going to need, let the questions be pull. Let them come out of what you're trying to do together, because that's going to give them a framework to hang that understanding on.
Do you feel like there is, when these questions pop up, do you think there's a benefit from documenting some of the answers along the way? Or is this like best just to let these things kind of organically pop up and have those conversations and know that the team's going to kind of, thinking of like teams that are trying to scale quickly or something, which for better or worse might try to figure out, like, I know that we try to lean on documentation or FAQs or something like that. And I don't know how useful those always are, but.
That's a good question. If you have an FAQ page that you can search, that might be useful. But in general, documentation is for people outside the team. Documentation is essential when you're offering a service and you expect people to be able to use it without talking to you. But within the team, I don't think documenting that stuff is going to help. You're going to have all the problems of documentation being out of date or in the wrong place. Now, if there's like a spot in the code or in the software where you can put a hint to make the software teach the people who have the question, this is the same thing in a good user interface, where if you hover over a field, you get some answer of what that field is, or like if you can change the software such that it is self-documenting in that way, awesome. But in general, no, we're not supposed to have our software documented. It does require us to be actively on the team and in the system.
I'm thinking about this scenario where there's developers joining a team, and maybe on the flip side, let's say they're the new developer joining a team. What advice can you offer them on how they can best acclimate themselves? Let's say that if their team doesn't have a plan in place outside of being like, all right, we're going to start throwing some projects your way and throw you in the deep end and let us know if you have questions.
Oh, God. Like, working alone at that point is going to be impossible for months. That's just normal. And if your team expects you to be able to work independently on an existing project within a few weeks, they're wrong. And that's dangerous. And if you feel stupid, well, you're the one who's correct there. It's not that you're stupid because it's not about you. It's what you're asked to do is stupid. But in general, there are things you can do when you're not pairing, when you're poking around alone anyway, and while you're waiting for people to be available and stuff like that. If you have a problem, that's a good entry point for questions in the system. And you can go just dig around. See if you can find tests. Ask people where to find the tests so that you can change the tests, see what happens, and start digging in and doing experiments on the code. Because I think that, like in life, when we work with software, learning about it and changing it happens at the same time. So if you can get an environment set up where you can fiddle with stuff and do experiments, you're going to be able to get a grasp of what's going on a lot more easily. And more importantly, you'll be able to form hypotheses and then test them. So if you can get an environment set up to do experiments, that helps a lot. And whenever you do have a question, try to spend a little extra time learning, dig a little deeper, and see if you can get at some of the underlying principles. And when you come to something and you are asking people questions about it, or you're working with someone, try to get at the why. Like, you want stories. Okay, you're not like, geez, who wrote this code? This is crap. But what's the story behind this code? When it was written, how was the context different? And often if you get to hang out with people who've been at the company for a long time, you get some interesting stories about, oh yeah, it used to be really important that the system did this thing. Now hardly anybody does that. And this other thing is much more important. And so many more things will make sense.
I'm also thinking about the scenarios where you're a developer that takes over a project and maybe there's no other developers there to answer any questions because maybe you're a freelancer or I'm a contractor. You know, my company, we do contracting. And so we take over projects from other agencies, or maybe there was a string of freelancers, or maybe they had a few internal developers at some point and they couldn't afford to keep that as a model anymore, or they lost their last developer. And there's no one to tell the story except for, say, a stakeholder that happens to oversee the project. And they may or may not even have a story that's, as long as the code base, because maybe they join the project later. So there's just these artifacts of code and a thing running.
Yeah, that's where you get to Google code archaeology and learn those skills.
I've heard a couple people describe themselves as code archaeologists. And so I think that's pretty accurate there. Any tips for them on how to start navigating that? I mean, I would assume that most people aren't just falling into that scenario unless they were being hired as the only developer at a company. But if they're a consultant, I'm sure they're hopefully have some experience doing that, and they're not doing it for the very first time on a project. But at some point, that may happen for the first time, and they'll hopefully learn through it. And
here's one idea. What you want to know at that point is how the software is used. What code in there even matters? I would insert events into the code, even structured logs, or preferably events, but like with Honeycomb. But structured logs will do. Add log statements at parts where you think it's probably important, entry points, and anything else that looks particularly scary or interesting. And then deploy those into production. This also gets you comfortable deploying into production and have that experience under your feet. And then find out whether indeed, are these the entry points people are using? How often are they used? Who's using it? And then you can, if you're lucky, if it's internal software, you can go talk to those people and ask them what they're doing and how their experience of the software feels. And you might learn this thing that you thought was important actually just gets in their way. Yeah, so get the software to teach you about itself.
The deployment ones, I think that's a really, really good one as well. It's something that we often try to be mindful about when we're taking over new projects. Is one of the things we wanted to demonstrate to a new client is that we can introduce a really small change and feel pretty confident that we can actually get it pushed out to, say, staging environments and production environments, so that when they actually have, they probably have a long list of things that they really want you to work on, bigger, important things, and those are going to be a lot scarier to push out initially. So if you're making some schema changes to your database, or you might need to roll back or something, and let's not have that be a first thing. Commit to some smaller steps and get the deployment process, build some confidence in your team that you can even do that, so that you're not
put the tape down on the floor and the ceiling before you get the paint out.
Exactly. So you touched earlier on being a Symmathecist. Where could people learn more about what that means? You touched on it. I know you give longer talks, and I'll include a link to one of your talks. I know that a couple of my developers on my team saw you speak at RubyConf late last year, and so they had some nice things to say about that. Is this something that people can find a lot more literature on?
Yeah, if you go to blog.jessitron.com, you can find my blog posts, and you can search the blog for Symmathecist, which is Symmathesy. Nope, I spelled that wrong. Let's try that again, Jess. It is hard. Symmathesy. From the Latin sim, together, and mathesy, learning. Yeah, that's the best place. Also, you can follow me on Twitter at Jessitron, Jessitron.
What non-programming book do you find yourself most often recommending to people in our industry?
Most often recommending. I'm really fond of Ecology, the Ascendant Perspective. This is a systems thinking book. I mean, it's talking about ecology, but it's about systems that form feedback loops that sustain themselves and grow as a unit. That was one of the biggest inspirations for my thinking of software as Symmathecist.
Interesting. I'll definitely include a link to that and check that out myself. Well, it's been such a delight having you on Maintainable, Jessica. Thank you so much for joining us.
Thank you, Robby. This was great.